Consider the following scenario when answering the rest of the examination paper unless otherwise stated or the question are of a general nature. Fairly Fit is a fitness center being established in a local shopping mall. They offer customers gym facilities such as weight room, swimming pool, and sauna, and a health food cafe. Question 3. Application. The business owners will need various computer hardware items for the fitness center. To reduce startup costs, they have purchased a second-hand server with the following specifications. Now, let us address a matter. Whenever students see something like a server, they think about this endless row of sophisticated computers that goes completely over their head. Obviously, the examiners do not want you to think about such things. They don't want you to get stressed whenever they write server. A server is simply to be thought of as a normal computer that has extremely high specs. That's all it is. Now, with that idea in mind, let us move on. 3.1. Let us move on with the specifications. An Intel Xenon CPU with 8 cores and 3.3 GHz. 2 CPU slots, 1 is filled. 20 MB level 3 cache, DDR3 RAM, 8 RAM slots, 3 x 2 TB HDD, supported RAM chips, 2 GB, 4 GB, 8 GB, 16 GB, and 32 GB, 4 x USB 3 slots, Intel onboard graphics card. 3.1. Give an example of one device which will connect to a server via USB. Now, with what I previously advised, what can you tell me will be able to connect to your computer either at school or at home? The answer is simple and straightforward. Either a mouse, a keyboard, or even a printer. Now, those are the 3 most likely answers because they are easy to think about and they're just asking for one device. 3.2. The specification doesn't state how much RAM there is on the motherboard. What is the maximum amount of RAM which can be installed using? The first one, 2 GB. The total amount of RAM is simply 2 GB times the number of slots that they are. So 2 times 8 is what? Exactly, 16. Next, 32 GB. 32 times 8 gives us 256 GB. Let us move on to 3.3. 3.3. An operating system is critical to the operation of any computer. 3.3.1. What are the 3 basic functions of an operating system? The first function of an operating system is to provide a user interface. Think about it. Whenever we load up our computer, we're given this beautiful interface, and we're not given codes like what it used to be or how we see it in movies. The next function is that it runs programs. Now, when it runs, we mean it loads, it executes, and it terminates programs. The third function is that it manages computer resources. There's a spelling error there, sorry. So those are not the only things that a computer operating system does. Those are just the 3 most basic ones that the computer operating system must do. Think about it. We've learnt about BIOS. BIOS checks every single thing that is functional on a computer's hardware system. And then it gives the rest of the operation to the operating system. Now, the operating system does a lot. And these are the 3 gists of that lot that it does. 3.3.2. The server does not include an operating system. Complete the following table to suggest an operating system suitable for the server in this scenario. You need to name one operating system, give one reason to justify your choice, and name the license model used for the operating system. Now, we can really choose any operating system. We just need to be able to describe those 3. The first one that I chose was Windows. Then the second one was Ubuntu. I chose Windows because it is one of the most widely used and recognized operating systems in the world. Now notice that I have these things highlighted. The highlighted part are all you really need to write. I just wrote more information so that we can understand this. Let us continue. I chose Windows because it is one of the most widely used and recognized operating systems in the world, with a large market share and a vast array of software applications available for it, making it a popular choice for both personal and business use. I chose Ubuntu because it is one of the most popular and widely used Linux distribution, known for its user-friendly interface, stability, and large community of users and developers. Now, we've just named the operating system and we have justified our choice. Now, for the last one, we need to name the license model used for the operating system. The license model used for Windows is an End-User License Agreement, EULA. Windows is released under a proprietary license model, specifically the End-User License Agreement, which is a commercial license that restricts the use, modification, and distribution of the software. The EULA license model means that Microsoft retains ownership and control over the software, and users are only granted permission to use it under certain terms and conditions. Now for Ubuntu. Ubuntu is released under the GNU General Public License, which is a free and open source software license that allows users to freely use, modify, and distribute the software. The GPL license model ensures that Ubuntu remains free and open source, and that any modifications or derivatives of the software must be released under the same license. Now that we understand, we move on to 3.4. Users wish to improve the performance of computers. 3.4.1. The specification states 2 CPU slots, although only one is currently used. If a second processor is added, would this be considered a coprocessor? Justify your answer with one reason. Yes or no. Now the answer here is no. However, the memo's correct answer was yes. So now why am I saying no? Well, that's easy. I asked an AI. Specifically, I asked 3 different AI, and they gave me somewhat 3 similar answers, supporting the no option. The first one is Meta AI. A coprocessor is a specialized processor that assists the main CPU in performing specific tasks, whereas adding a second processor to the second CPU slot would be considered a multi-processing or dual processing configuration, where 2 identical CPUs work together to share the workload and improve overall system performance. In this case, the second processor would be a peer to the first processor, and not a specialized assistant, and therefore not a coprocessor. Copilot. A coprocessor is a specialized processor designed to handle specific tasks and supports the main processor, such as graphics or mathematical calculations. In contrast, adding a second processor in a dual CPU system means both processors share the workload of general computing tasks, rather than one supporting the other in a specialized role. ChatGPT. A coprocessor is a specialized processor designed to handle specific tasks or operations, such as floating-point arithmetic or graphics processing, which complements the main CPU. In contrast, adding a second processor to a system that supports multiple CPU, often referred to as a multi-core or multi-processor system, means both processors are used to handle general computing tasks, essentially working together to increase overall processing power and efficiency. They share the load of regular computational tasks rather than focusing on specialized functions. Thus, the second processor would be considered another main CPU rather than a coprocessor. The justification there is based on the essence of what a coprocessor is. Now that we understand why no was chosen as the answer, let us move on. 3.4.2. Multitasking and multi-threading are 2 commonly used techniques to improve performance. Define each of these concepts and give one example of how each can improve performance. The highlighted part can be taken as the answer. So now, let us start with multitasking. The definition. Multitasking is a technique where multiple programs or tasks are executed simultaneously by the operating system, sharing the same resources such as CPU, memory, and input-output devices. Now, the example. A user is working on a document in a word processor while also listening to music and browsing the internet. The operating system switches between these tasks quickly, giving the illusion that all tasks are running simultaneously. This improves performance by increasing productivity. The user can work on multiple tasks simultaneously, reducing time spent switching between applications. Now, if you are a student and didn't think of this, shame on you. This is the most comprehensive and relatable example you'll ever get in this topic. Multi-threading. Multi-threading is a technique where a single program or process is divided into multiple threads, each executing a separate part of the program's code. These threads share the same memory space and resources, but can run concurrently, improving responsiveness and throughput. The example. A web browser uses multiple threads to load a web page. One thread loads HTML, another thread loads images, and another loads the JavaScript. This improves performance by improving responsiveness. The browser can display the HTML content quickly while images and JavaScripts are loaded in the background, making the web page load faster and more responsive. Now, all of you should have by now noticed that whenever you open a web page, the text comes out first, then the image, video, and whatever else is there. This is us literally experiencing the multi-threading process. Let us move on. 3.4.3. The processor has 20 MB of level 3 cache. A. What type of RAM is used in processor caches? The answer here is SRAM. Static RAM. Now, what are caches? Caches are automatic storage for frequently used data. So now, the question lies, what is static RAM? Static RAM is a type of volatile memory that is faster and more expensive than dynamic RAM. Dynamic RAM is the one that is used in the actual RAM, the main memory. This is important for the processor cache, which needs to provide data to the processor quickly to avoid slowing it down. Low latency. Static RAM has a lower latency than dynamic RAM, which means that it can respond quickly to requests for data. The third one is high bandwidth. Static RAM can transfer data at high speeds, which is important for processor caches that need to handle large amounts of data. The fourth one, low power consumption. Static RAM consumes less power than dynamic RAM, which is important for processor caches that are often located on the same chip as the processor. So now, static RAM is used in various levels of processor caches, including level 1, level 2, and level 3 caches. So now here is a depiction of what it would look like. There is the CPU, then there is the level 1 cache, the level 2 cache, then the level 3 cache, then the main memory which uses dynamic RAM. Level 1, level 2, and level 3 caches are all static RAM. So now the capacity of level 1 cache is 16 to 64 kilobytes. I know, it's very small. Level 2 caches are typically 256 to 512 kilobytes. Then finally, level 3 caches are typically 2 megabytes to 8 megabytes. But in this case, we got 20 megabytes for level 3 cache because it is a server. So now that we understand this, why does level 1 cache have so little space? The reason is this: the less space you have, the less things you're able to put in that space. And the less things you're able to put in that space, the faster it is for you to look through everything and move on to the next step. Level 1 cache and level 2 cache typically serve a single processor. The reason is because of the amount of space that it possesses. You can't share stuff that has so limited space. So now level 3 cache is the one that is typically shared because of the amount of space that it has. Now, because we understand the main purpose of a CPU with all the calculations that it needs to do, it needs to be able to access frequently used data as quickly as possible. The amount of time that it will take the CPU to reach the main memory will not be affected by the number of caches that are in between the two. In this way, if the CPU is able to find what it is looking for in level 1 cache, or level 2 cache, or level 3 cache, then that means that it will be able to respond far faster, thereby increasing proficiency. Letter B. Will it be possible to increase the size of the level 3 cache to improve the performance of the CPU further? Justify your answer with one reason. The answer there is no. It may not be possible to increase the size of the level 3 cache to improve the performance of the CPU further. Why? Increasing the size of the level 3 cache would lead to increased latency. As we discussed earlier, the larger the size, the more things you're able to put within, and the more things that you're able to put within, the more time you'll take looking through all those stuffs. So now let us continue. Increasing the size of the level 3 cache would lead to increased latency, as the cache would take longer to search and retrieve data from the larger cache, potentially offsetting any benefit from the increased cache size. This is known as the cache latency trade-off, where larger cache can lead to slower access times, diminishing the performance benefits. Letter C. Caches can either be shared or unshared. Shared means that each core of the processor makes use of the same cache memory. Explain why level 1 cache is more likely to be unshared compared to level 3 cache, which is often shared. The reason is this. Level 1 cache is more likely to be unshared compared to level 3 cache because level 1 cache is typically smaller and faster and is designed to serve the immediate needs of a single core. The characteristics. Its proximity. Level 1 cache is located closest to the CPU cores. It is designed to provide the fastest possible access to frequently used data and instructions. The size. It is also relatively small compared to the others. The memo states that level 1 is more likely not to be shared as it is smaller and closer to the CPU, or more likely to have the instructions which a particular core is wanting. 3.4.4. The server has an onboard graphics card. True or false? An onboard graphics card makes use of system RAM. Support your answer with one reason. The answer there is true. Onboard graphics card, also known as integrated graphics, use system RAM, which is the main memory, as their video memory. Unlike dedicated graphics cards which have their own dedicated video memory, integrated graphics cards share the system's RAM for storing graphics data and textures. This is because the onboard graphics are integrated into the motherboard, or CPU. As a result, the system's RAM is allocated part of its resource to handle graphics processing tasks. This shared memory approach can impact overall memory performance since the RAM is used for both general computing tasks and graphics processing. So your answer there could be the IEB's answer. It needs RAM in order to manipulate the graphics. So now, why is it needed in a server? Integrated graphics cards are designed to be more power effective and cost effective. And using system RAM helps to reduce the overall cost and power consumption of the system. Letter B. Regarding the current scenario, would you recommend that the owners use an additional graphics card in the server? Justify your answer with one reason. The answer is no. Why? There would be no graphics demanding programs that would be run on the server. The question specifically asks us to regard the scenario. The server's primary role will be handling administrative tasks such as managing memberships, processing transactions, and possibly supporting a small number of digital displays for in-house information. Integrated graphics, as included in the Intel onboard graphics card, are generally sufficient for these functions. They can handle standard Office applications, web-based tools, and basic graphical interfaces needed for server management. Additional graphics cards are typically recommended for tasks that involve high-resolution graphics, intensive rendering, and specialized applications that require significant GPU power. In the context of a fitness center server, focusing on membership management, point-of-sale systems, and basic operational needs, integrated graphics are adequate. Adding a dedicated graphics card would not provide substantial benefit and could unnecessarily increase costs without improving the server's core functionality. Now that is just an explanation. The answer, no, there would be no graphics demanding programs that would be run on the server, is more than sufficient. Letter C. Name 2 components that will be present on a dedicated graphics card that improve the computer's overall performance. The answer is GUI and video RAM.